Hello, everyone. This is Noah Housley again with Chem 105 Practice. I wanted to go over you see this big paper of like lots of writing on it, but I'm gonna try. What I'm doing is for these tests, we have to know the scientists and what the scientists did. So this is a scientist review and trying to make it kind of simpler. So first, there's really three categories that all these scientists fit in. Okay, and these aren't in order from date. It's not first year and then last year. These are all kind of intertwined, but it's split up, and at least she split it up into category of what they accomplished and what the topic they did. So the first topic is what does the atom have / look like? So what's in the atom was basic. And so first, Greek started with just the four elements, and then there was alchemy, thinking you could turn one element into another. And so then there was, and I had another video kind of memorizing these things, but there was Boyle, who presented modern view of elements. He said there are elements, not just earth, fire, water, and air, like Avatar. Antoine Lavoisier, I don't know how to pronounce that, he came up with the law of conservation of mass. So just remember Lavoisier, law of conservation of mass. Joseph Proust for proportions, came up with the law of definite proportions. Not to be confused with multiple proportions, which is what John Dalton came up with. So Proust is for proportion, for definite proportions, because proportion definitely sounds like Proust. And John Dalton is for the law of multiple proportions because he has, I don't know, a good one, remember that one. But where he said that elements combine with different masses with another element, they are in the ratio of the same whole numbers. So like if you have 10 grams of carbon mixed with 5 grams of helium, then you can also have 10 grams of carbon mixed with 7.5 grams of helium, and that ratio will always be in small whole numbers. So in that case, it was 2 to 3. J.J. Thomson, this is easy to remember because he discovered the electron with the cathode ray. So really, we can split this up into another section. In here, these are just concepts. Not really down, these are really concepts that needed to happen to discover that there are atoms, but these are really concepts to say, Boyle represented there are elements, mass is conserved, and then within that conserved mass, there are the same amount of proportions of elements in that mass, and then within the mixture of masses, they react with each other in definite proportions. And so from this, they said, okay, there has to be atoms. So then J.J. Thomson discovered the electron. So now these are going into parts of the atom. So we get the electron from him. We get from Millikan and Fletcher, we get the mass of the electron and the charge of the electron. They had the oil drop experiment. Marie Curie, remember she was the only girl, and so she's saying radioactive. She discovered radioactivity, that things decay. And then Ernest Rutherford, he discovered the nucleus by that deflection experiment. He shot stuff, and then stuff came back at metal, and stuff came back. And then James Chadwick discovered the neutron. You remember that in Jimmy Neutron, I think Jimmy Neutron's real name is James, so it's James Neutron. So James Chadwick came up with the neutron. Rutherford came up with the pi, the what's it called? The fig cake, the something cake, where it's just like chunks in it, but it's more like what we see today because the neutron was discovered as well. Okay. Then we get into another category of just learning that things come in packets of energy rather than a constant flow of energy. And so that's where we get Planck's constant, and then Albert Einstein said that light is in photons and light is in packets of energy. Those are kind of easier to remember. Then we have Joseph von Fraunhofer. And so Fraunhofer discovered that there are lines in that spectrum from that experiment, that the light from the sun is not a continuous spectrum. And then Bunsen, for the Bunsen burner, that one's easy to remember, he burned elements and discovered that elements burn, and those lines matched up with the lines that Fraunhofer discovered. So then we have Balmer and Rydberg that came up with this equation that discovered the wavelength of these electrons that are really these integers that are from the difference of these elements. And then that's where Bohr came up with his model. And we know the Bohr model, that one's easy. And then Louis de Broglie, he came up with that matter moves in waves from this equation. And then moving on to Werner Heisenberg, he came up with the uncertainty principle. I remember this one because I'm pretty uncertain how to spell Heisenberg, and I'm also uncertain on where the electron is. So that's where that principle came up with. Then Erwin Schrödinger, he came up with the equation for allowed energy states of the electron. This is the really long one with psi in it. And so Erwin Schrödinger, I'm not sure, I don't remember that one either. So these are the scientists. Just remember, just think in your memory, think, okay, you've got the kind of the more unfamiliar ones are like Balmer and Rydberg. Both their name is Johann and Johannes. So if it's a Johann or Johannes, they came up with this equation. Another one, Erwin Schrödinger, is a good one because he came up with orbitals. So Erwin orbital, maybe. Rutherford is the pie one, the plum pudding. That's what it is, the plum pudding. Marie Curie is the only girl in here, and she came up with radioactive, so she's saying radioactive. And then Millikan and Fletcher, they were the two that did the oil drop experiment. Hopefully these are good to know, good to review.